Next, let us look at an insight into weighted average. Once I know that the question is on weighted average, what data do I search for in the question? What is the anatomy of such a question? It seems that let's say there's a part 1, there is part 2, each one having a different average. I also need to know the weights related to the two parts, and when the parts are combined together, I would be getting average of the two together. So it seems that there are 5 set of data, 1, 2, 3, 4 and 5. Are they really 5? Do I search for all 5 of them? Let's look at it through an example. So the example is a simple one which we did last time. So let's say there's a group of girls with an average age of 20. There's a group of boys with an average age of 30. Let me assume the number of girls as 10 and the number of boys as 40 to keep our values simple, to keep our calculation simple. What's the average of the boys and girls considered together? So we have done this yesterday, so it has AR is nothing but 20 into 10 its weight plus 30 into 40 divided by 10 plus 40. We have done the same values yesterday, so I am just doing it a little fast. 200 plus 1200, that is going to be 1400 by 50, which will be 28. Right? So the average is 28. Look at the change that I am doing here now. What instead of 10 and 40, if the number of girls were 5 and the number of boys were 20? Let's recalculate it. So 20 into 5 plus 40 into the weight being 20 people. Now the number of people or the sum of weights in this case is 5 plus 20, that is 25. So I get 100 plus 800 by 25, which is 900 by 25, and since I have to divide by 25, oh, I made a mistake. The average here is 30 and not 40. So that will change this to 600 and the sum is going to be 700. Since I have to divide by 25, I can easily multiply it by 4 and divide it by 100. Cancel 2 zeros. So into 4 is going to be 28. So what I see is the answer is the same in both the cases. So what's happening? I hope you would have noticed this. The numbers have been halved. What is the concept of a weight? It's a weightage, the importance attached. We know average is sort of a tug of war between A1 and A2. That one who has a more importance, more weightage will pull the average towards itself. Now this weightage is not entirely dependent on the numbers themselves. It is on the relative strength of the two groups, right? By relative we mean the ratio more importantly. We could say boys' years are, in the first case, 4 times the number of girls. In the second case also they are 4 times the number of girls, right? So the influence, the weightage that the boy group exerts on the average is going to remain same in both the cases, right? So if you have got the meaning, what I am saying is these numbers themselves are not important. What is important is the ratio between them. The ratio of the weights is more significant, and it's rightly so. The formula that we have, let's say instead of weights, I have the actual weights, I only know the ratio of the weights. So I could assume the weights to be individually as W1K and W2K. So if I write the formula out over here, A1 W1K plus A2 W2K divide by sum of weights W1K plus W2K. What we see is the K in the numerator can be taken common, K in the denominator can be taken common, and it will cancel out. So could I have used the values that are available in the ratio format itself? Pretty much, right? So hope this makes this clear that weights themselves are not important. What is important is the ratio of the weights. So let's get back to our anatomy of the question. Are there 5 individual pieces of data that is important? No. The weights individually are not important. What is important is only the ratio of the weights. So I would just say that there are 4 pieces of data that are needed. One are the individual averages A1 and A2. Next is not the individual weight, the ratio of the weights. I'll count it as just one data, ratio of weights, and obviously the resultant average. Out of the 4, 3 will be given and the 4th will be asked. Is this insight only about reading a question faster? Not really. This insight can help make a very difficult question into a very, very simple one. Right? Let's see it through an example. So the tough question is, alloy 1, 12 kgs of alloy 1 has P1% iron in it. 6 kgs of alloy 2 has P2% of iron in it. And it's given that P1 is not equal to P2. Now, X kgs are taken from each of the alloys and are fused together with the remaining part of the alloys. Right? So there's an interchange and they're fused together, the remaining part of the other alloy. The resulting alloys, let's say alloy 3 and 4, have equal percentage of iron. Find the value of X. It's a little complex question to understand. It would take some time. So I would suggest pause the video, solve it, and then continue. If you have given it a decent try, at least the question should have understood as, I have 12 kgs and this is alloy 1, let's say, which has P1 percentage of iron in it, and I have an alloy 2 which is 6 kgs, alloy 2 which has P2 percentage of iron. Now I am taking X kgs from here and X kgs from here, fusing it with the remaining part of the other alloy. This is how I would be resulting into, let's say, alloy 3. So let's take the first and this part as alloy 3. So what will the weight out over here be? If this is 12 kgs, this is going to be 12 minus X kgs. If this is X, this will be 6 minus X kgs. So in alloy 3, I'll have 12 minus X kgs with a percentage of iron being P1 is mixed with, is fused with X kgs of alloy having percentage of iron P2. This is my alloy 3, and alloy 4, the remaining part, the X kgs having percentage of iron as P1 is fused with the remaining part of the other alloy, which is nothing but 6 minus X kgs having P2. So these two are fused, and it is given that the percentage of iron in the alloy 3 and 4 are equal. I want to find the value of X. So there are two sort of weighted average situations. There's a part 1, part 2 mixture, part 1, part 2 mixture, and the percentage same. So let's try to do it algebraically. So P1 is the average into the weight, which is 12 minus X, plus P2 is the average into the weight X over sum of weights. Okay, I'll write it completely, 12 plus X, which is going to eventually be just 12. And the percentage of alloy here is P1 has a weight of just X, P2 has a weight of 6 minus X, sum of weights X plus 6 minus X, again we see the X cancels out, and 6 and 12. The 6 will cancel out over here with the 2. The 2 are given to me as equal, therefore the 6 cancels out with the 2. I'm multiplying it and as well as rearranging. I'm getting all the P1 to one side. So I'll have P1, 12 minus X, there's a 2X here, will come here, will become a 12 minus 3X. What about P2? The 2 is going to be multiplied over here, so there's a P2. 6 2s are 12 minus 2x, and a term from here, x will come here, will be a minus x, so I get 12 minus 3x again. I'm doing this fast because I've given you time to solve it on your own, or else pause the video, do the calculation in a more elaborate manner and see. And what do we see now? If I cancel out the 2, then it results in P1 is equal to P2. But the question explicitly states that P1 is not equal to P2. So there's a mystery involved. And that mystery is, if the two sides are equal, before cancelling, we need to ascertain that it is not 0. But since I know this is not the case, P1 is not equal to P2, I cannot cancel the two sides. And when is it that I cannot cancel it? That is the only cases when that is equal to 0. So if 12 minus 3x is equal to 0, both the sides can be equal with P1 and P2 being different values, right? And so if 12 minus 3x is 0, this will straight give us x is equal to 4. So pretty interesting question. It's one of the good questions to understand. Has taken us this amount of work. It took us some time to understand and then doing this work. However, as we said, the concept of knowing that the weights themselves do not matter, it is the ratio of weights that matter, which can make this question very, very easy. And how is it? I know that the average of P1 and P2 is equal to PR. That's it. And the average of P1 and P2 is again equal to PR. Both are equal. So P1 is same as P1, P2 is same as P2, PR and PR, the resultant averages are also same. So how are the two situations different then? Why are they different? I have different weights. The weights themselves may be different, but what is constant is the ratio of the weights has to be same. If the average of P1 and P2 is PR and the average of P1 P2 is also PR, then whatever is the weights in the two cases, the ratio has to be same. So the question in the most simplest form, it is just understanding this part and saying, oh, the ratio of the weights has to be equal. That's it. So I don't need to do any other work, and this on cross multiply, 12 6 are 72, minus 12x minus 6x is minus 18x, minus of minus is plus x square is x square cancels out, and I straight get 18x is equal to 72, that is x is equal to 4. Hope now you understand that knowing that the ratio of weights is important more than the actual weights themselves can conceptually make a question very, very easy. We'll end the session by just pointing out that this concept of weighted average can also be used in data interpretation, and pretty widely actually, right? So just to give you a snapshot of it, let's say a data question talks about sales values from Jan to June. That's the first half of the year, and the sales is given into a pie chart. The sales value is given as 2,275 million rupees, whatever. And one of the sector represents a net profit margin. You don't really need to know what its meaning is or so on. So it's just 18%. You just need to know 18% is of this value. And a similar pie is given for July to December. And July to December, the sales value is 1625, and the net profit margin here is 16%. The question is asking us what is the net profit margin in percentage for Jan to December. So it's a classic case of weighted average. I have part 1, the first half Jan to June, second part July to December. The question is asking about the two parts taken together, right? So obviously I'm sure it doesn't take a lot of efforts to get to know that 18% is of 2,275. The profit in first half, in second half it is 16% of 1625. The profit in second half, this is the total profit. I want the profit as a part of sales. What's the total sales? Plus 1625. Now, my problem is students solve it this way and then they crib that DI has a lot of calculations. The idea was not to make you do this calculation. The idea was to check, instead of using the actual sales value, do we use the ratio of the sales value? And this ratio of sales value is not just important in weighted average year. This says if I know the ratio, there are many questions by which I could substitute the actual value with the ratio. So I see that 25 cancels both of it. So rather than take the actual values, I'll just take the ratio. 25 nines are 225, or 2 is left over, 25 ones are 25. 25 6 are 150, 12 is left over, 125 is this. Oh, I see that it can be further reduced by 13, 13 sevens are 13 5s. So the ratio was 7 and 5. So a lot of comparison question can simply be done by taking this as 700 and this as 500. But that is maybe in DI. For weighted average, all we are left here is I need the answer also in percentage. So I'll drop the percentage also. 18 has a weight of 7 and 16 has a weight of 5. And the sum of weights is 7 plus 5. So which is nothing but 70 and 56. 126 plus 80 by 12, which is 206 by 12. 12 ones are 12, 8 is left, 7s are 84, 2 by 12 is 1.6, 166. So that's the answer. Hope you understand weighted average can be applied in a lot of scenarios anywhere, whether it's quantitative or whether it is data interpretation.